Number 4, you might notice there's a decimal, and you might think, I don't like that decimal. Well, then change it. The chump way to read that would say 0.0001. The correct way to say that would be to say 1/10,000th. That's the correct way. So this is log base 10 of 1/10,000ths. We could then say, I want to change that fraction to a base of 10. 10 to what power is 10,000? 4. This is 1/10,000th, so it's -4. The negative just means it's a fraction that's flipped over. So this is log a base 10 of 10 to the -4, because 10 to the 4th is 10,000, which makes this equal to a -4. I'm going to do number 5 by setting it equal to a variable. Do it either way, it doesn't matter. If I change this to exponential form, I'm saying 2 to the x equals 1 divided by 32. One divided by 32 should be able to be written as a base of 2 to an exponent. 2 to the 5th is 32, therefore 2 to the -5th is 1/32, which makes x -5. Ideas for number 6? There's a common mistake people make on this, and I hope someone suggests that mistake so we can learn from it. You should be thinking log ID number 2 looks pretty nice right now. Take a gander at log ID number 2. It says if you have a base to an exponent, and that exponent is a logarithm with the same base, the answer is just the argument. Do you all see that? Certainly that applies to this problem. So what would that make this problem equal? It is not 2. It is not 6. Here's the problem that we have. We can't use that ID yet because there is this coefficient for our exponent, this 3. Explain how it's 8. But not can be, we should move it there. Let's do that first, and then you can continue. Using the, go back to our properties. Using the power property, it works both ways. You can take an exponent for an argument and move it to the front of the logarithm, or you can take the coefficient of the logarithm and move it to the exponent. Works both ways. So that's what Snorlax wants to do. So we got 5 to the log base 5 of 2 cubed. Just move the coefficient to be an exponent. Continue, sir.
Following students need to report to Mrs. Christmas room.
Right, 2 cubed is 8. Now this is in this exact...
Haley Macbeth, Sean Mills, Melvin Stevens, Spencer Hines.
Sorry,
Jeremy
folks at home, we
Fisher,
have announcements right now.
Maple, Jake Pieper, Denny Farrell, Taylor Gray, Ian Maltier, Josh Schweitzer, Alex Schaefer.
Maltier, that is French. Maltier. Mr. Maltier. Using log ID number 2, we can now say this is 8 because our base of 5 and our logarithm's base are the same, so the answer is just the argument. Questions? solve each equation. You have to use your properties to do these equations. If, yes sir. It is maybe. Explain. Okay. Product property is correct. And how would that help us? Arguments. How do you know that you are multiplying, that you should multiply the arguments? It's correct, and because you're adding those logarithms. It's excellent. And then continue, sir. Well, I thought that you knew how to solve the problem. That's what I meant. Cannot do that, sir. If you look at the property of equality, it says that if you have one logarithm on each side of the equation and they have the same base, you can just set the bases equal to each other. So at this point, we have one logarithm on each side of the equation. They have the same base of 6. Therefore, we can say that 9x is 54. And now we don't have any logarithms at all. We're just doing algebra 1. Divide both sides by 9, and you get x is 6. Number 2 here, we would like to use that same property of equality because we have one logarithm on each side. They have the same base. The problem is the one on the right has this coefficient of 2/3. We have to get rid of that 2/3 somehow. Snorlax. That's what he said. It's not funny when you say it like that, is it? Now we have one log on each side. They have the same base. There's no coefficients. We can just simply say that the argument on the left is equal to the argument on the right. What is 8 to the 2/3? Using one of our definitions of rational exponents, we can write this as the cubed root of 8 squared. Cubed root of 8 is 2. 2 squared, I didn't laugh, is 4. Thank you, Mr. Huggins. I did. I had many peanut M&Ms. Many. I had an exorbitant amount. Thank you, Mr. Huggins. Mr. Huggins was the only graduate of the state of Ohio that he was all Ohio in 2 states for basketball his senior year. In 2 states? How do you do that? The guy did it. When he was in college, he would... I'm still rolling. When he was in college and he would go to practice, he would tell his teammates, you know what, today feels like Dunk Tuesday. I said, Mr. Huggins, what does that mean? He said, I'm just going to dunk every time I get the ball. And they would get so mad because they couldn't stop him. You could have been Ohio in 2 states if you lived on the border. Yeah. I didn't notice that. Have a good day, sir. He really was amazing. Could have been pro if he wanted to be, but he didn't care about that. He cared about coming here. I guess the bell's going to ring. Have a good day, folks. We have 10 minutes. Suggestions for example D, number 3. Yes, sir.
Move the 4 that's in the front to the exponent for the x.
It's a great idea. Move the 4 to an exponent for the x. Do we have to do that? Can we just use the product property right now? Take a gander at the product property real quick. Product property says if you have 2 logarithms with the same base and you're adding them, you can just multiply the arguments. Can we just do that right now? Cannot do that right now. The reason that we can't do that right now is because of that coefficient in the front. We have to move it. So if you move that to be the coefficient, if you move the coefficient to be the exponent, you're going to have log base 2 of x to the 4th. Plus log base 2 of 5 equals log base 2 of 405. That's great. Excellent work, Kyle. Any suggestions what we could do next? Miranda. I think I just say Miranda. Just comes off the tongue real naturally. Log base. And then you say of. That's correct. Because at this point, we are now using the product property. Once again, which says if you have 2 logarithms with the same base and you're adding them, you can write it as 1 logarithm and then multiply your arguments. That is great. Any ideas what we could do next? Miranda. Do you know what property that is, ma'am? It's a property of equality. Property of equality, which says that if you have a log on each side of the equation and they have the same base, no coefficients, you can set the arguments equal to each other. To solve this equation, you're just using algebra. Divide both sides by 5. You get x to the 4th equals 81. Then to get x by itself, you do the 4th root of both sides. When you do the 4th root, anytime you do an even root, it's supposed to be plus or minus. What is the 4th root of 81? 3. However, the answer is not plus or minus 3. If we go back